What's up, everybody? Happy Friday. Um, I'm excited to get into lesson number 2 here of your first unit. We're going to be doing comparing and ordering decimals today. So yesterday we talked about decimals and place values. Today's going to be about how to compare them, tell which one's bigger than another, how maybe to put them in order from least to greatest. I promise today no mints will be harmed. I went a little overboard yesterday. I understand. So I'm going to keep it down today. So let's start off. Vocabulary for today. The word round. The word round means to adjust the value of a given number to a given place. Now that sounds kind of weird, but it's basically just taking a number and adjusting it to something that's close to it. Okay, and we'll talk about a little bit more about that in just a second. But first, there's a couple symbols that I need you guys to get familiar with, and that is the less than symbol. Right? If you want to tell that something is less than something else in mathematics, we use obviously a lot of symbols. But the first one we're going to look at is the less than symbol, and that looks like this. And my favorite way to talk about the less than symbol and why it looks like that is because it's kind of like an L, but just kind of scrunched over. So L for less than, but kind of scrunched over. The next one is the greater than symbol. And the greater than symbol looks just the opposite of that, right? Because greater than is the opposite of less than. And then finally, the last one, hopefully you got this one down by now. It's the equal sign, right? So those are the symbols we're going to be using today. And again, this stuff's up in your activities, so you guys should be able to reference that if you need to. Next, we're going to start talking about how to round a decimal. Okay, so in order to round a given decimal to another place value, you got to know which place you're rounding to. Okay, so the example here is to round these numbers right here to the nearest tenth. Now, if you remember from yesterday on our place value chart, the tenths place is the place right after the decimal. So we need to look at the number to the right of the given place value. So the first number, let's just do 2 and 64 hundredths for our first one, right? So we need to round to this place, the tenths place. So in order to round to the tenths place, we look to the place to the right of that, the right. So we look to the 4 over here. And then we have to make a decision, right? Down here in step number 2, it says, if that number is 4 or less, then the place value does not change. But if it is 5 or more, so if this were a 5 or higher, then this place would change. We'd bump it up. Okay. But it's a 4. So that means that this number doesn't change. So what we would do is just evaluate that at that point and say 2.6 is what it's going to be, because we looked at the 4 and it is 4 or less, and tells us to keep it the same. So then what you do is every number after that place that you just rounded to, every number after the 6, we drop off. So instead of this being more complicated, rounding makes it less complicated because it makes the number smaller. Well, not necessarily smaller, but less complex, to just 2.6. So instead of 2.64, like, well, let's just round that to something a little bit easier to work with. So we're going to round it to 2.6. Now let's look at the other number, 5.87. We've got 5.87 for our number, and we want to round to the nearest tenths place, which is this place right here. Then we have to look to the number to the right of it. And in this case, we see that the number to the right of it is a 7, which according to our rules over here means we have to bump this up when we round. So we're still going to drop off everything after it. But what do we have to do this number here now? Because it's a 7, we actually have to take it and make it a 5.9 in this case, because that 7 told us to bump it up to a 9. And that's a little crash course on rounding. Again, you guys have practiced this before, but hopefully this is just kind of a review or to kind of get you going for the rest of the year. So let's do a couple of comparing and ordering problems here real quick. Do some examples, and then you guys should try them on your own, okay? So the first one here is comparing 4.672 And if we were to say that number properly, be 4 and 672 thousandths, compared with 4 and 703 thousandths. Now, if you really think about that, if you could just say the number, you know which one's bigger. Because you've got 4, and then you got 672 thousandths, versus 4 and 703 thousandths. Well, 703 thousandths is more than 672 thousandths. So we kind of probably already know that this one's going to be bigger. But what if these numbers are a little confusing? Well, what's a good way to find out? Well, you start by looking at the first place that they have in common, right? And we look at their ones place. They're both 4 something. So we can't really compare and know which one's bigger by looking at that. That's just a 4. So we say, okay, well, if the 4 is the same, then what should I do? I'm going to move over to the next place to the right and compare that number. So then if we look over at the 10th place, we see that this number has a 6 and this number has a 7. So now we have an idea. Oh, well, this has 7 tenths and that has 6 tenths. So we know that this number is bigger. And then if I were going to compare these numbers, this is exactly what I would do. I would say 4 and 672 thousandths is less than 4 and 703 thousandths. That's how we would put that answer for that type of problem, right? That number is less than that number. Next one, example number 2. We've got 2 and 83 hundredths compares to 2 and 8 tenths. Now this one's a little weird because they don't have the same places. So what it tells us here is to actually put a 0 on the end of this number, because it says adding a 0 to 2 and 8 tenths does not change the value of the decimal. It's needed so we compare the same number. You can put as many zeros as you want on the end of a decimal, and it doesn't change the value of the decimal. It's still the same value. So we're allowed to do that. So what do? Same thing as the last problem, right? We start with the ones place in this case, but we can't really figure out anything about it because they're both a 2. So they're the same? Not quite, because they have more, right? They have decimals. So then we move over and we look, and there's 2 8s. Again, same problem, right? 2 8s we can't compare. They're basically the same number at this point, right? Wrong, right? We got to go one more place over. We find out, oh, okay, this is where they're different. 2.83 is definitely bigger than 2.80. So then we can go back to look at our original numbers and say that 2 and 83 hundredths is greater than 2 and 8 tenths. One more for you guys. Example number 3. 6 compares to 6.0. It's kind of tricky. This is what I want you guys to do. Go ahead and put 6.0. You tell me. How does 6 compare to, oh, this is not a 0, guys. Sorry, I use this to put my signs in. This is where less than, greater than, equal to goes. How do they compare? Well, since adding a 0 behind the decimal does not change the value of 6, these two numbers are the same. If you said you had $6 and I said, well, I have $6.0, it's the same. So we would say that those numbers are equal. All right, I got a couple practice problems for you guys to do in this lesson. Thank you for watching my video. Thank you for paying attention. Go ahead and go to the activity, answer a couple questions for me. Again, a lot like yesterday, not too bad. And then you're done. Happy Friday. Enjoy your weekend. And I'm excited to get into some stuff next week. See ya.